Okay, so this is going to be some of the missed questions from the Unit 1 exam. So here we go. The first one is graph the following rational expression. So I think I'm going to zoom in just a little bit so everyone can see the question. And then what I'm going to notice is if I look at this function, notice it's undefined at x equals -1. All right, Trig, can you move? Come here, Trig. Thank you. So it's undefined definitely at x equals -1. But we need to decide if it is a asymptote at x equals -1 or is it a whole. So what I'm going to do is I'm going to look at the function and see if I can factor the numerator. Now the numerator can be factored as x plus 1, x plus 1. So I can cross out that one factor and I get x plus 1. So even though this is unit 1, we know later that we can call that a removable discontinuity. So what we have there is a whole, right? So I don't have an asymptote there at x equals -1. The other thing I'm going to notice, at this point, we hadn't talked about limits. So if I took the limit as it went to infinity, well, if we think about it now, we know that the limit goes to infinity. But the way that we thought about it at this point, we said, okay, well, the degree of the numerator is bigger than the degree of the denominator, so there is no horizontal asymptote. So we have no asymptotes. All we have left is this right here, which is a line with a y-intercept 1 and a slope of 1, and we have a whole at -1. If I plug in 1, that's going to tell me where that hole is. So at, whoops, if I plug in -1, that's going to tell me where that hole is. -1 plus 1. So that hole is going to be at 0. So at -1, 0, there's a hole. I have a y-intercept of 1, and it's just going to look like a line. So all of these have asymptotes, so I know those aren't the numbers, aren't the answers. And this one has a negative slope, so that's not the answer. So this is the correct graph. All right, next question is find the limit as x goes to -infinity of e to the x. Well, to be able to do this one, well, there's a couple ways you can think about it. Really, the best way is to know what the graph of e to the x looks like. And they gave you what the graph looks like. And we're going to -infinity. And as I go to -infinity, I know that e to the x has a horizontal asymptote at 0. So as I go to -infinity, I get really close to 0, but I don't touch it. So the limit as I go to -infinity is 0. And then the question is, well, where does e to the x have a horizontal asymptote? It has a horizontal asymptote at 0. So our next question, solve the equation for e to the x minus 3 equals 17. Well, when we have questions that are in exponential form, either they have the same base and we set the exponents equal to each other, or we take the natural log of both sides. You could also take the log of both sides, but since this one has a base e, I'm going to take the natural log of both sides. So I have e to the x minus 3 equals 17. I'm going to take the natural log of both sides. So natural log of e to the x minus 3 equals the natural log of 17. And I do that because the law of logarithms is if I have the natural log or log of something raised to the power, I can bring that exponent out in front. So I have an x minus 3 e, natural log of e equals natural log of 17. Now I know that natural log of e is equal to 1. So what I have left is x minus 3 is equal to natural log of 17. I'm going to add 3 to both sides, and so I get natural log of 17 plus 3. Now they tell me to round to 4 decimal places. So I have natural log of 17 plus 3. Now when I put it into my calculator, I get a 5.8332133344. So they say to round to 4 decimal places, which is that one right there. And that's a 1, so I should get 5.8332. All right, pay special attention to the directions right here. I feel like when I was going through partial credit on Unit 2 and Unit 3, a lot of people were missing points just because they were not answering in the correct format. Sometimes they would say answer in a fraction, some would say a decimal, and we were answering the incorrect way. And I would give partial credit for that, but not full points for that. All right, the next question is solve this inequality. X minus 19 over X minus 20 is greater than 3. Now, usually the natural instinct people want to do is they want to cross multiply. But what happens is we lose where it's undefined. So what you want to do is you want one side to equal 0. So what we're going to do is we're going to subtract 3 from both sides. X minus 19 over X minus 20 minus 3 is greater than 0. All right, I'm going to find a common denominator. That common denominator is X minus 20. All right, this left side already has the common denominator. The second term on the does not have the common denominator. So I'm going to multiply it by X minus 20. I'm going to write it all over the same common denominator. And make sure you don't forget to distribute this negative sign. So I have an X minus 19 minus 3 times X minus 20 is greater than 0. And now I'm going to distribute that 3. So minus 3x plus 60. And x minus 3x is going to give me a negative 2x. And 60 minus 19 gives me a 41. Over x minus 20. And then what we say is we have critical points where the denominator equals 0 and the numerator equals 0. Now this is completely different from the critical points that we talk about when we're talking about derivatives, all right? But the critical numbers are where the numerator and the denominator equals 0, and that's what we're going to put on the number line. All right, the numerator equals 0, 2x plus 41 equals 0. So that is where 2x equals 41, or x equals 41 over 2. The denominator equals 0 at x equals 20. All right, and those are the numbers that I'm going to put on my number line. So 20 and 41 over 2 is just bigger than 20. All right, and I'm going to see where it's positive and where it's negative. All right, I'm plugging in here. right? Is it positive? Is it negative? If I plug something in the interval less than 20, let's plug in 0. I have 41 over negative 20, so that's something that's negative. All right, now choosing a number between 20 and 41.2 is not very easy because 41 over 2 is what? 20.5. So let's plug in 20.1. All right, if I plug in 20.1 in the numerator, I'm going to get what? A 40.2, and that's going to give me something negative. If I plug into the, wait a minute, 2 times 20.1, yeah, that's going to give me 40.2. That's going to give me something positive, right? And then if I plug in, that's going to give me 0.8. If I plug in 20.1 in the denominator, that's also going to give me something negative, right? 20, yes. So that's going to give me something positive. What am I doing wrong here? So 20.1, the top is going to give me something negative. The bottom is going to give me something positive. So that's going to give me something negative. Let's try this one more time. So negative 2 times 20.1 plus 41 over 20.1 minus 20. So negative 2 times 20.1 plus 41 gives me 0.8. Okay, so I get something in total that is positive. Sorry about that confusion. All right, now if I put something bigger than 41 or 41 over 2, let's just say 30, then I'm going to get something negative on top and something positive on bottom. So I'm going to get something negative. Now I have a greater than sign. So I want things that are positive, right? Now I know I can't equal 20 and I don't have greater than or equal to. So both of these are going to be open circles. And I want things that are greater than, so that means I want things that are positive. So I want the things that are positive are between 20 and 41 over 2. All right, next question. For each of the following, find for each of the following where f of x equals 3x plus 7. So first, we're going to start with, here's my function, 3x plus 7. A is just find f of x plus h. All right, so that is going to be 3x plus h plus 7. So I'm just going to distribute the 3, and I get 3x plus 3h plus 7. All right, that's it. For part B, they want f of x plus h minus f of x. Let's move this over here. Well, I already have f of x plus h. That's 3x plus 3h plus 7. Now I want to subtract off f of x. Well, f of x is just my function. So minus 3x plus 7. If I subtract off 3x minus 7, that gets rid of this and that gets rid of this. So I end up with just 3h. Part C wants f of x plus h minus f of x over h. All right, well, we know what the numerator is. It's just 3h. Then over h, cancel our h's, and we just get 3. All right, next question. Now they want us to find the limit as h goes to 0 of 2 over 5 plus h minus 2 over 5 over h. And we should notice that this is what? This is the derivative of f of x if f of x were equal to 2 over x, I guess, at 5. F prime of 5. All right, so the limit as h goes to 0 of 2 over 5 plus h minus 2 over 5 over h. So maybe the easiest way is to multiply the numerator and the denominator by the common denominator in the numerator. Or let's just go ahead and find the common denominator in the numerator. Let's start there. So the common denominator, let's not lose our limit, is going to be 5 times 5 plus h. So 5 times 5 plus h. So the first term had the 5 plus h, but not the 5. So I need to multiply the numerator by the 5. The second term had the 5, but not the 5 plus h. And then we're going to write it over the same common denominator. So I have a 10 minus 2 times 5 plus h over 5 times 5 plus h over h. Let's go ahead and distribute that -2 so that I have a 10 minus 10 minus 2h over 5 times 5 plus h over h. My 10's cancel. And I'm going to erase some things because I'm out of room. And let's move it up. And I get -2h over 5 plus h over h. And I forgot to mention this at the very beginning, but remember we can't actually plug in 0 because if I plugged in 0 to that denominator, it'd be undefined. So that's why we are having to do some algebra. Now, you can think of this as multiplying by the reciprocal of the denominator, where you would just multiply the top by 1 over h. Or you could think about it as multiplying the top and the bottom by the common denominator, which is 5 times 5 plus h. Either way, you're going to get the same thing. So if those cancel, you're going to get the limit as h goes to 0 of -2h over h times 5 plus h. And what happens now is our h's cancel so that we are able to now plug in our 0 for h, a -2 over 5 times 5 plus h. So if I plug in 0, I get 5 5 plus 0, and I get a 5 times 5, which is 25, and I get negative 2 over 25. And that's it for that one. Next question is find the domain of this function. Now, when we think about domain, we think about what can't be in our domain. And we should think about things that make the denominator 0, things that make the square root negative. It can equal 0, but not negative, can be underneath the square root. And everything that's in a logarithm has to be positive. All right, so things that are in a logarithm, a log, so let's say I had log of x, then everything has to be positive. If I have the square root of x, everything has to be greater than or equal to 0. All right, anything underneath the in the denominator can't equal 0. So in our case, we would think, okay, well, I need everything underneath that square root to be greater than or equal to 0. Well, not in this case, because that also happens to be in the denominator. So I need to say that 7x squared plus 6x minus 1 needs to be greater than 0. And then I'm going to factor. So I'm going to have a 7x and an x. Both of these are going to be 1. I need the one that multiplies with the 7 to be positive and the other one to be negative. My critical points in this case are going to be x equals 1/7 and x equals -1. I'm going to put those on a number line and see where they're negative and positive. If I plug in -2, that first product is going to be negative, and the second one is also going to be negative. So that is going to be, wait a minute, positive. If I plugged in 0, because that's a number between -1 and 7, I'm going to get a negative times a positive, so that would give me something negative. If I plugged in something bigger than 1/7, let's say 5, I would get something positive and something positive. So that would give me something positive. And again, I can't equal -1 or 1/7 because that would make the denominator equal to 0. So, and I need everything to be positive. So this is where my solutions are going to be. So the domain is going to be -infinity to -1, union 1/7 to infinity. And that's it for that one. All right, next question is we're going to find the limit as x goes to 36. Now we can't plug in 36 here because that would give me 0 in the denominator. So frequently when we see square roots in this class and we have limits, we should think about multiplying by the conjugate. So that's what I'm going to do. I have the limit as x goes to 36, the square root of x minus 6 over x minus 36. So the conjugate of the numerator is the square root of x plus 6. Remember, I have to multiply the top and the bottom by the same thing. I'm going to FOIL out the numerator, but I will not FOIL out the denominator. Maybe I move this down here. Right, if I multiply the square root of x times the square root of x, I get x. If I get multiply square root of x times 6, I get 6 square root of x. If I multiply -6 times square root of x, I get -6 square root of x. And if I multiply -6 times +6, I get -36. Right? And like I said, I am not going to multiply the denominator out. So I have x minus 36 times the square root of x plus 6. All right. The 6 minus x and -6 plus, 6 squared of x minus 6 squared of x cancel. That's the whole point of multiplying by the conjugate. So what happens is I get an x minus 36 on the top, and I have that same factor in the denominator. So those cancel. And I have a 1 on top and the square root of x plus 6 in the denominator. Now I can plug in my 36 for x. So I get 1 over the square root of 36 plus 6, which gives me 1 over 6 plus 6, which gives me 1 over 12. And that may be, oh, not the last one. All right, so this function, or this question asks me for the domain as well. And again, we talked about this. We need everything in the logarithm to be positive, not equal to 0, because you can't take the natural log or the log of 0. So I need x squared minus 25 to be greater than 0. I'm going to factor x squared minus 25, and that's x minus 5, x plus 5. So the critical numbers I'm going to have are 5 and -5. I'm going to put those on my number line. If I choose something less than -5, let's say -6, I'm going to get a negative times a negative, which is positive. If I plugged in 0, I would get -5 times +5, which is negative. If I chose something bigger than 5, say 6, I would get 1 times 11, so that would be positive. I want things that are greater than 0. I can't equal 0, so those are open circles. So my domain is going to be -infinity to -5, union 5 to infinity. All right, next question. Solve this logarithmic equation. So I have log base 5 x plus 115 plus log base 5 x minus 5 equals 4. All right, anytime that I'm solving a logarithmic equation, I want the logs on one side to be written as one log. So I want to use my law of logarithms. If my logarithms are being added, I can write them as a product. So log base 5 of x plus 115 times x minus 5 equals 4. Now we need to remember, if I have log base b of x equals y, to rewrite that as an exponential, that means b to the y equals x. So I'm going to rewrite this as an exponential because I don't have logs on both sides. If I had logs on both sides, I can set the insides of the logarithms equal to each other, but that's not the case. So I have 5 to the 4th equals x plus 115 times x minus 5. All right, so I need to figure out what 5 to the 4th is. 625. And then I'm going to FOIL this side. So x times x is x squared. Outer is x times -5, which is -5x. Inner is 115 times x, so plus 115x. And last is 5 times 115. So minus 575. All right, so those are some ugly numbers. And now we need to subtract 625. Okay, so my factors are x minus 10 and x plus, whoops, I thought I had it, x plus 120. All right, I don't know why I didn't see that at first. Okay. Now, so that gives me answers, x equals 10 and x equals a negative 120. All right, now, remember, we always have to check to see if our solutions work, because remember, we can't take the log of a negative number. Now, if I plug negative 120 in there or there, I'm definitely getting an extraneous solution, right? I get a log of a negative number. So definitely negative 120 does not work. Let's just go ahead and check that log 10 works. So log base 5 of 10 plus 115 plus log base 5 of 10 minus 5 equals 4. So log base 5 of 125 plus log base 5 of 5 equals 4. So 5 to what power gives me 125? Well, that's 3. 5 to what power gives me 5? Well, that's 1. And 3 plus 1 is 4. All right, so my answer is x equals 10. All right, next question. They give us, to produce X units of religious metal costs C of X equals 18X plus 142. The revenue is R of X equals 125X. Both cost and revenue are in dollars. So they give me a cost function and they give me a revenue function. They want me to find the break-even quantity. So that's when cost and revenue are equal. So I'm going to set revenue equal to cost. So 18x equals, 18x plus 42 equals 25x. So let's subtract 18 from 25. And I get 7. So 42 equals 7x. And that means x equals 6. So 6 units will let us break even. The next question is find the profit from 460 units. So next what we need is we need a profit function. And profit is revenue minus cost. So P of X is going to be 25X minus my cost function, which is 18X plus 42. 25X minus 18X, we already said was 7X minus 42. And they want us to find the profit from 460 units. So we want P of 460. So 7 times 460 minus 42. So 7 times 460 is 3,220 minus 42 gives me 3,178. All right, part C asks, find the number of units that must be produced for a profit of 70. So I want to set profit equal to 70 and solve for x. So 70 plus 42 is 112. And I'm going to divide by 7. And I get x equals 16. So 16 units. All right, next question. I think this is the last one. So we're going to factor. And if I remember right, the problem that a lot of people had on this one is they thought it was an equation. And so they were multiplying both sides. But it's an expression, not an equation. So I can't multiply both sides by something, right? It's just an expression. So I'm going to start by just rewriting it. All right, and notice that this one has a negative exponent. So I'm now going to rewrite it with that one in the denominator. So I have an x, 8x plus 5 squared over x squared minus 2 to the 1/2 plus 8x squared minus 2 to the 1/2, 8x plus 5. I'm going to write them with the same common denominator. And since the right term does not have a common denominator, the common denominator is just going to be x squared minus 2 to the 1/2. So x squared minus 2 to the 1/2, x, 8x plus 5 squared. So I'm going to multiply the top by the same thing. Now notice I have an x squared minus 2 to the 1/2, and I have another x squared minus 2 to the 1/2. Well, if I multiply those two together, right, it's the same thing as adding the exponents, which just gives me 1. Or remember that x squared minus 2 to the 1/2 is the same thing as the square root of x squared minus 2. If I have 2 of those square roots, I'm just going to get what's underneath the square root. So now what I'm going to do is I am going to write them over the same common denominator. So now this side is just going to have an x squared minus 2 to the 1/2. Oops, I lost my squared. Whoops. Not going to have a 1/2. It's just going to be the power of 1. And then I have an 8x plus 5 all over x squared minus 2 to the 1/2. All right, now I'm going to do a little bit of erasing. Now I'm going to factor out things that the numerator has in common. Well, each of them has an 8x plus 5 in common, right? The first term has 2 of them. The second term only has 1. So I'm going to factor that out. So the first term, what's left over is an x times an 8x plus 5. And the second term has an 8 times an x squared minus 2. All right, now I'm going to go ahead and move this back up into the numerator, right? Both terms are over it, so I'm going to put it back up here. So I have a x squared minus 2 to the negative 1/2. I have my 8x plus 5. Right now I'm going to distribute my x, so I have an 8x squared plus 5x. Distribute my 8, so plus 8x squared and minus 16. And I'm going to add my like terms. So 8x squared plus 8x squared is going to give me my 16x squared. And then I have a 5x and then a minus 16. And that is my answer. And I think that's my last one because we already did that one. All right, so that is the end of the Unit 1 review.